This is the video for section 6.3, and in this section we're going to talk about square root functions and square root inequalities. So first of all, if a function contains the square root of a variable, then it's called a square root function. And the square root function is a type of radical function. Okay, and so here is our parent function, f of x, or y equals the square root of x. Here's what that graph looks like. Okay, so it starts at 0, and it just is this, it's kind of like a sideways parabola. Okay, but it doesn't have this other side to it. Okay, now if I put a plus or minus in front of this, it would look like the sideways parabola. Okay, so it is just this graph right here, and whenever we start graphing this, we're going to do a table so that you can get some actual points so that you know how wide or how tall to make this graph. But the domain of this, it will start at 0 and go on. So x is greater than or equal to 0, or sometimes we would write that like 0 to infinity. My range, how far up and down does it go? Again, it starts at 0 and goes, it's f of x is greater than or equal to 0, or y is greater than or equal to 0, or we could write it like this again. My intercepts, my x-intercept and my y-intercept are 0. It's not defined where x is less than 0, so there's no part of my graph on this left-hand side, and that makes sense because if x were -1 or any negative number, that's an imaginary number. Okay, and then it describes its end behavior as x goes to 0. Okay, then f of x, which y goes to 0. As x goes to positive infinity, so as I go to the right-hand side of my graph, f of x, or y, goes to positive infinity. So this gets higher and higher and higher as I go. Okay, so that's what our parent function of the square root of x looks like. So we're going to be talking about transformations of this parent graph. Okay, so we've done transformations before. If you'll remember, when we were doing like the absolute value of x, okay, we know that its graph is a v. Well, remember if I had, okay, x, the absolute value of x minus 1, anytime I have a number inside the absolute value bars, or if it were a parabola inside the parentheses, this number shifted it to the left or to the right, but in the opposite direction. Okay, so same thing applies for the square root function. All right, this is what this horizontal translation says. Okay, if I have the square root of x, and I have a number like the square root of x minus 3. That means instead of starting at 0, I'm going to shift my starting point for that parent graph to the right 3. And the graph would look something like that. Okay, so horizontal translations is when the number is underneath the radical and we always go the opposite direction. Okay, now vertical translations, going back over here to my absolute value, remember if I had absolute value of x minus 1 and that minus 1 was on the outside, that means that my parent graph was shifted down 1 unit. Okay, well, same thing for square root functions. If I have a number outside, so here's my parent graph. If I have a number outside of the square root sign, like this, okay, that means my parent graph, instead of starting at 0, it's going to be shifted up 1 unit. Okay, and we'll do more examples like that. And then sometimes you're going to have a number like 2 in front of the square root. Okay, if there's a number, and here's what they're talking about, a, it's going to change the orientation and the shape of the graph. Okay, if a is less than 0, so if this number is negative, the graph is reflected across the x-axis. So instead of opening up like this, it's going to be opening down like this. If the absolute value of A is greater than 1, the graph is stretched vertically, and that's just like we've had before. And if the absolute value of A is between 0 and 1, so if it's a fraction less than 1, the graph is compressed. Okay, so we're just going to look at some examples of that. So this says identify the domain and range of the following. Okay, so first of all, the domain and range, okay, of our original function both started at 0 and went to infinity. All right, so identify the domain and range. So first of all, we could graph these and look and see what the graph looks like, but we should be able to tell just by looking without having to graph, okay? This graph, square root of x plus 4, since the 4 is underneath the radical, it's going to shift my parent graph left or right. We always go the opposite direction, so this is going to shift my parent graph to the left 4. My parent graph would look something like that. Okay, so my domain, instead of starting at 0, my domain starts now, my x values start at -4. So my domain would be -4 to infinity. My range, how far down and how far up it goes, that didn't change. So my range is 0 to infinity. Okay, and we could graph that. You could graph that in your calculator just to confirm that that's what that graph looks like. Now this one, how is this going to be shifted? Since the 3 is underneath the square root sign, okay, it's going to be shifted to the right 3 units. That's what that graph would look like. So now my domain now starts at 3 and goes to infinity. My range has not changed, 0 to infinity. And see, I'm using the brackets because this number is included in the domain and the range. You use a parenthesis when that number is not included. So infinity is just the concept of a number, so I need to use a parenthesis. Okay, this one has a vertical and a horizontal translation. This 6 underneath says I'm going to move it to the left 6, 1, 2, 3, 4, 5, 6, and up 2. So there's what that graph looks like. Shifted to the left 6, up 2. Okay, it doesn't have to be nice and neat right now. We're just finding the domain and range. So my domain for this is going to start at -6 and go to infinity. My range, now my lowest point is at 2 to infinity. Okay, and again, we could put these in our graphing calculator just to verify that that's what those graphs look like. Okay, so now I know you don't have this on your paper, but somewhere I want you to write this on your sheet because I want you to know how, when you're sketching this, what points to use. Okay, so these are the exact points for our parent graph. We know that when we're graphing this, the parent graph starts at 0. Okay, so I have the point 0, 0. Now let's plug in 1. When I plug 1 in, okay, square root of 1 is 1. So I have the point 1, 1. Let's put the point 2 in there. So the square root of 2. Hang on one second. Yep. Okay, so square root of 2. I'm not sure what that is, but we can put that in our calculator. Oops. So square root of 2. Whoops. Is a little almost 1.5. Okay, so we'll say 1.4. So at 2, it's 1.4. At 3, do you see if I plug in 3, I'm going to get another decimal. So let's choose 4 because the square root of 4 is 2. Okay, so 1, 2, 3, 4, 1, 2. Okay, my next perfect square, let's say 9 when x is 9 because the square root of 9 is 3. So at 9, it is 3. So this will give me an idea of when I sketch my graph, how far up, how far down I need. So 0, 0 would be a good point, 1, 1, 4, 2, 9, 3. All right, so let's graph each of these functions. So I know that this is going to be shifted to the right 2, 5, 1, 2, 3, 4, 5. So there's my starting point. And then normally, let's go back and look. My next point would be to the right one, up one. So I can kind of go from here. This is going to look something like that. My domain for this would be 2 to infinity. My range would be 5 to infinity. Okay, now this one's going to be changed a little bit. I know I'm going to go to the left 3, 1, 2, 3, down 1. There's my starting point. Okay, so this -2 right here is going to change it. First of all, instead of opening up, it's going to be opening down. Okay, it's going to go this way. So if you have a number in front, then you need to use your little a t-chart. Okay, we know we're starting at 1, 2, 3 at -3. So when we plug -3 in, okay, I get 0 here. So -2 times 0, that's -1. All right, well, I already have that point. Okay, so let's choose our next number. Let's choose -2. So I'm going to plug -2 in. So that's going to give me, I'm going to work it out here, -2. This is -2 plus 3, so that's 1 minus 1. Square root of 1 is 1. So that's -2 minus 1, so that's -3. So I have the point -2, -3. Whoops. -2, 1, 2, 3, -3. Okay, let's choose another number. I'm going to choose -1, -0. I'm going to choose 1. Okay, so when I plug 1 in, okay, do you see right here? I'm going to get 4. So -2 square root of 4 minus 1. Square root of 4 is 2. So -2 times 2. So that's -4 minus 1. So that's going to be -5. So at 1, I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This point right here must be wrong. Oh, no, it's not. See, here's what it looks like. Okay. So my domain, let's start at -3. So -3 to infinity. My range, this time my highest point, is -1. And how far down is it going to go? It's going to go to -infinity. So really, I don't write it -infinity, right? We always start with our smallest number, so it's going to be -infinity to -1. And this is a parenthesis right there. So that is my range. Okay, now the last type of problem that you're going to have is same thing, but we're going to be graphing an inequality, which means we're going to be shading part of the graph. So this translation says I'm going to moving it to the right, 1, 2, 3, 4, and down 6. 1, 2, 3, 4, 5, 6. Okay, so I'm going to sketch this in. I know my next point is always up 1 to the right 1. Okay, this is going to be a dashed line. All right, remember less than or greater than is dashed. If it has the equal to sign, that would mean it's a solid. And since it's less than, I'm going to shade below. If it were greater than, you're going to shade above. So shade below would look like this. And then we will do the last example in class together, either Friday or Monday.